Hi, it's a real pleasure to be back with RPPW, even if it is just virtual. And I'd now just like to share my screen. So what I'm going to do is actually start with a slide from the last time I gave a presentation at RPPW, which was in 2005. And I was talking about different roles for auditory cortex in processing sound with a particular relevance for delayed auditory feedback. And the context I was using here is this evidence now that has been growing over the past couple of decades, that if we look within the auditory fields in primate brains, we see distinctly different anatomical and functional streams of processing. So running forward down the temporal lobe in these kind of rostral fields, we have in non-human and human primates, brain areas that are particularly interested in the recognition of and sort of structure in sounds we hear. So for example, speech in the spoken voice. And there are also these more caudal pathways shown here in blue, which are found in non-human primates and human brains, which are associated more with sensorimotor processing in relation to sounds and action. So for example, we find cells of brain areas back here which are associated with the production of speech, even if the production of that speech is silent. So it's kind of an acoustic guidance of articulation. So we very crudely call these pink areas a what pathway and these blue areas a how pathway. And we published a paper in Nature Reviews Neuroscience in 2019, arguing that one of the things that distinguishes these two pathways is the temporal response characteristics of these rostral and these caudal fields. So these pink areas tend to be slower and more sustained in their responses. These blue areas tend to be faster and more transient in their responses. So for example, you get strong responses to the onsets and offsets of sounds in these caudal, these posterior auditory fields. Now, so just to show what and how. Now, this is just showing you the distinction in a brain imaging study where we contrasted listening to speech versus speaking. So when you're listening to people speaking, these more anterior auditory fields shown here in yellow are recruited, whereas when you yourself are speaking, there is a bigger emphasis on these posterior auditory fields curling up into the parietal lobes. Now, of course, those aren't the only areas associated with speech production, and actually there's a very well delineated set of brain areas associated with the motor control of speech. You get bilateral activation in the sensory motor cortex. We get left and right activation in the supplementary motor cortex, in the cerebellum, in the basal ganglia, and we also get a left lateralized network. So we get the left classic inferior frontal gyrus, Broca's area, and anterior insula, just sort of adjacent to that, are both left lateralized responses associated with speech production, and also one of these posterior auditory fields here, this area I was alluding to before, which is associated with the control of speech, even if the speech is silent. And interestingly, these left posterior fields do seem to play a slightly different role, just even anecdotally, in rhythm in the voice. So this is a study where we actually had people speaking in different conditions, and we were looking for speech production networks. And actually within this, people had 3 different speech tasks to do. So they were speaking aloud and answering questions about where they lived and things like that. So propositional speech, you're generating what you want to say. We also had 2 more constrained speech production conditions, people counting aloud, 21, 22, 23, and also people producing highly overlearnt pieces of poetry like nursery rhymes, Humpty Dumpty sat on a wall. And when we look within this, there was actually some sensitivity within these left lateralized regions associated with some of the rhythmic characteristics of what people were saying. So particularly this left posterior auditory field running very medially was much more strongly associated with the production of the rhythm in, well, these very highly structurally rhythmic nursery rhymes than it was for either the counting or the propositional speech, although it is relative to not speaking, still strongly activated by speaking. So it's being recruited even more when you are inflecting perhaps rhythm and structure onto in a highly sort of stereotyped way onto these nursery rhymes. It is worth noting there's probably more going on here. There's something interesting happening, for example, in the anterior insula and counting. But for now, let's just think about this posterior auditory field, part of this auditory how pathway. And we were interested in what might happen in this field when people speak synchronously. Now, speaking synchronously is something that Fred Cummins has talked a lot about in his papers and in his papers at RPPW meetings, because what happens when people speak synchronously, so they're just going to read aloud from the same text, is you find people are quite good at it, and they're very, they can start to converge their voices very tightly, and they do so by really starting to exploit rhythmic and in pitch intonational characteristics in a very kind of stereotypical way associated with the speech that they're producing, and they know what they're saying because they're both reading from the same text. So these two women are producing joint speech. The woman on the left is a woman who stammers, and she's producing joint speech as a way of demonstrating how her voice changes. So you'll hear she's slightly different at the start, and then you'll notice that her voice quite quickly changes.
Here. So we'll start here and we'll read together, okay? A 60-year-old woman suddenly developed partial paralysis, weakness in her left leg while sitting in the same posture for sewing. Within 24 hours, the paralytic attack was replaced by involuntary movements in her leg and arm. She was admitted to the hospital. On testing, she exhibited the following signs.
There we go. So you can hear that before and afterwards there, she's a stammerer, she's somebody who stammers, and there were periods within that when the voices were completely aligned. Now, and again, you can also hear that they were speaking quite slowly, they were clearly coordinating their breathing. There's a lot going on here. But we were interested in this, and we took it into the scanner in collaboration with Fred. And this is not easy to do in functional imaging because you can only have one person in the brain scanner at a time. So one person was outside in the scanner room, one person was in the brain scanner, and we had different conditions. So people were either listening, the person in the scanner was either listening to speech, or they were being prompted to speak aloud, or they were speaking in a joint speech condition with the person in the scanner room. And in those conditions, they either spoke with that person in the scanner room live, as you just saw, except now in two different rooms, or they spoke aloud to a recording of that person. And in fact, those did give you slightly different results. If we concentrate on the speaking with the person who is speaking live, what you see is this pattern of activation. So when someone is speaking, doing joint speech with another person, and that person, they are both live, no one's a recording, what you find is that predominant activation is seen in auditory fields running back, so back towards this how pathway, particularly actually now on the right. And we're also seeing a recruitment of Broca's area, that sort of left inferior prefrontal cortical field I said was strongly associated with speech production. We're now seeing that appearing on the right. So this is activation that is greater than listening to other people speaking or speaking on your own. This is the areas that are being recruited selectively to do this joint speech task. And this is quite striking. It's interesting to see the involvement of this how pathway. It's interesting to see involvement of the how pathway with a dominant effect on the right. And it's also very interesting to see this response in this right homologue of the left inferior prefrontal area that is strongly associated with the control of speech production. And in fact, we have seen this before. So this is a study by Katzenblank and Richard Wise of patients who have lesioned classic Broca's area, the left inferior frontal gyrus, and have had a period of having great difficulty speaking. They've now recovered some speech, and they were scanning the patients to see where they had shown a reorganization associated with this recovery, and it happens over on the right. So when people have lost left Broca's area, we start to see right Broca's area recruited to produce speech. And that's what you're seeing here. So that's a greater activation. That's this field here compared when they're speaking compared to when they're not speaking in other conditions. Now, strikingly, the exact opposite is seen for the control. So when people who have not got lesions to left Broca's area speak aloud and they strongly activate left Broca's area, they are at the same time actively suppressing activation in this right inferior frontal gyrus field. So it's not just the case that we recruit it on the left when we're speaking normally, and then if we have a stroke, there's reorganization and something's changing on the right. there is some dynamic system here that is actually suppressing activation of this bright inferior frontal field during speech production. And that changes as soon as you start speaking in a joint speech way. Maybe that's why it's helping people who stammer. So this is not the end of the story. This is just another piece of evidence that is suggesting that while there is a whole distributed network of brain areas that are associated with the controlled production of speech, there does seem to be a really important role for this how pathway on the left and on the right in actually engaging and aligning your voice with somebody else in a way that is strongly associated with changing the rhythmic properties of your voice and the intonational properties of your voice, with a further very interesting role for something very different happening in right Broca's area. Thank you very much. And thank you to all my colleagues, particularly Carl Jasmin, who was the author of the joint speech study. Thank you.